Quick disclaimer before this video starts, I lied about today's video was going to be more progress on the flight computer, but instead it is about the rocket. Enjoy! So first off, to design the rocket, I used an app called Open Rocket Simulator. What this does is you can build the rocket in the simulator and also simulate what's going to happen during launch. At the front there's a nose cone, and this protects the rocket from aerodynamic forces during launch. Next, there are bulkhead pieces which act as foundations to put things on. Next, we have a parachute that will slow the rocket down, and a shock cord so it doesn't rip off the parachute. There is an ejection charge over there, and a GPS. There is also a 9-volt battery, and finally the Opal flight computer. At the end of the rocket we have 4 sets of fins, and also a rocket motor that will be inside of the body tube of the rocket, which is basically just a fuselage. In the simulator you can only choose a purchasable rocket motor, but I will actually make the rocket motor myself. On the left there are options where you can make the model go into a 3D mode. Here is the model in 3D, and this is what the Skyro 1 rocket will look like, and you can change the appearance. I'm obviously going to change the appearance of it in real life because currently it just looks a bit dull and boring. Now there are 3 ways you can see this model, and this is the first version, and this is the incomplete version. This is just a rough model. Now the next version is the unfinished model, and it is just what it would look like if you were making it in real life, but obviously it's unfinished and there's no paint on it. And this is the final model, which is what it would look like if you fully made it. Now Open Rocket Sim has a thing which you can do simulations on, so over here you can put a new configuration and load a motor onto it, and also put in some other parameters. Now as you can see, you can create a new simulation. I've already done many of the simulations because you can see all of those little bars back there, and currently I can change the slight parameters that would happen during launch. So as you can see, I am putting in, what am I putting in? Oh, the length of the launch rod, which is the thing that will keep the rocket stable as it makes those few seconds going off the launch pad. Next I check the box to show all data when it's launched, and as you can see, this is the simulation it has ran. Now I am now showing how high it is going. Currently it looks like it went up to 3,500 feet, I believe. And then afterwards you can see a gradual slope down, and that is when it's under a parachute. Next you can see the vertical velocity, which is how fast it is going upwards. Now with the design we can actually hit about 0.6 Mach, which is 0.6 times the speed of sound. And at the top you can actually just look at the bars and it will show you all the stats that happen during launch. And also if there's a tick, that means there are no warnings and the rocket is safe to fly. But if there is an exclamation mark, that means there is a warning, and that means it is not that safe to fly, or it's just a warning. And that means the parachute could basically be ripped off. But that's just the rocket. Now let's go into the motor. Now first of all, to make a solid rocket motor you will need the following: the grain of propellant, which is the fuel mixed with the oxidizer, a liner which will hold the grains, and a case, usually made of aluminum or steel. Now you could have an extra tube before the liner, like my motor will have, but for simplicity I will show you it without it. And finally the nozzle, which can be made from graphite, steel, ceramic, epoxy clay, normal clay, or cast concrete. Now motors can have any amount of grains and usually one in a small rocket, but my rocket is quite large, so I will use 3 grains. The propellant I will be using is sugar and potassium nitrate, which is cheap and accessible. However, you can use many other propellants such as ammonium perchlorate or APCP, which is fairly common and was used in the Space Shuttle solid rocket boosters. Now first I will put my 3 grains into my liner. Notice how there is a hole running through the middle. This is so the motor can burn a larger surface area, producing more thrust rather than lighting only one end. Next we need to put a case over the liner, made out of usually aluminum to hold the pressure. And finally we put the nozzle in that will convert the high pressure into workable thrust. Now let's simulate what this motor will do. So we'll ignite it from the top and see what it does. As you saw, the propellant burnt from the inside out and burnt very nicely and produced probably a lot of thrust. Hope you found this video useful, and that is as much time as I have today. But thank you for watching, and if you liked the video, please like.